All right, so first one here, solving by graphing. Got y equals 2x plus 1, y equals negative x plus 7. So graph the first one. And remember, we're looking for the point of intersection. So we start with the y-intercept of 1, slope of 2. Graph that looks like this. Second one, y-intercept of 7, 2, 4, 5, 6, 7. Slope of -1. So we get a graph that looks like this. There's our point of intersection at 2, 5. So that would be the solution to our system. Remember, it's always got to have an x and a y value. 2, 5 for that one. Second one, solving by substitution. Since we have a variable on a side by itself, all we need to do is take this, plug it in for that y value there. Gives us 3x minus 2 times 2x minus 3 equals 5. Simplify the left-hand side. We're going to distribute that -2. So we get 3x minus 4x plus 6 equals 5. 3x minus 4x will give us a negative x. Subtract the 6 to the other side. X equals -1. So we got to divide by -1. We get an x value of 1. So we've done half the work. X is equal to 1. Plug it in over here. Y equals 2 times 1 minus 3. So we end up with -1 for y. So we get a solution of 1, -1. Okay, then on the last one, okay, we can either eliminate the x's or the y's. It doesn't really matter. Okay, so most people trying to eliminate the x's, so it means we need to multiply this entire equation by -3. So make sure we do that. We get -3x minus 12y equals a positive 18 now. Copy down the first equation. So now when I combine them, my x's cancel. I get -10y equals 20. Divide by -10. Y should be equal to -2. Plug it back into one of these equations. I'm just going to plug it into the top one. So I get 3x minus 4 equals 2. Add the 4 to the other side. 3x equals 6. I get an answer of 2, -2. Okay, kind of walking around. We definitely are going to need some more practice with that. Okay, so today we're going to take a look at turning word problems into into different systems. Okay, so what I want you to do right now, take a look at 6-21 here in the textbook. Okay, read this. Okay, determine what your two equations are. Okay, and what is the best way to solve. All right, so I've seen about three different ways people are trying to solve this, which is great. Okay, so you got Charles's tree starts at 3 feet and grows 1.5 feet every year. Okay, then you got Amy's tree, which starts at 0 feet and grows 1.75 feet per year. So one thing I've seen people do, okay, is make a graph, okay, which is fine. Let's say Charles's tree starts at 3 feet, 1, 2, 3, okay, and it grows 1.5 feet per year. So the issue with this is that we're dealing with decimals. So when we're growing 1.5 feet per year, okay, the half, not so difficult. Okay, so we get something that kind of looks like this. Okay, and then we have Amy's tree, which starts at 0, okay, growing 1.75 feet per year, makes it a little bit more difficult because we got to go up 3/4 each time. So then we go to 3.5. Okay, then we go to, just grab my calculator to make this a little bit easier on myself. We go to 5.25. 1, 2, 3, 4, 5. Then we go to 7. Then we go to 8.75. Then we go to 10.5. 12.25. Then we go to 14. Then we go to 15.75. Then we go to 17.5. Okay. It's getting closer and closer. Okay, but it's also going to be slightly difficult to tell when they're actually the same height. As you can see here, they've already started to kind of merge. I'm not sure exactly when that is going to be. Okay. The other thing I've seen people do, which is another way you could potentially do it, is by making a table. Like so. So let's say we got years, we got Charles's tree, we got Amy's tree. Okay, Charles going by 1.5. Not too difficult. Start at 3. Then we get 4.5. Then we get 6, 7.5. Then we get 9, 10.5, 12, 13.5, 15, 16.5, 18, 20.5, 19.5. 21 in year 12. Again, Amy's a little bit more complicated because it's dealing with 1.75. So we start at 0, 1.75. We get 3.5. We get 5.25. We get 7, 8.75, 10.5, 12.25, 14, 15.75, 17.5, 19.25, or finally landing on 21. So we know in year 12, okay, that's where they ended up being the same height. Okay, you can totally do that. Nothing wrong with that. We get the right answer. Only issue with this is, what if it was year 100 where they finally were the same height? That's a lot of work. Even just going to year 12 was not as fun as you would want it to be. Okay, so depending on how long it takes you to get there, okay, you could do that, make a table. Nothing wrong with that. Okay, so the third way I saw was that they wrote 2 equations. So Charles's tree starts at 3 feet and grows 1.5 feet a year. So they wrote that equation as y equals 1.5x plus 3. Amy's equation starts at 0, so I know her y-intercept is 0, and she's growing 1.75 feet per year. So I could write her equation as 1.75x. I don't really need that plus 0. Now I have a system. I'm going to use substitution and take this and plug it in for y. So I get 1.75x equals 1.5x plus 3. Which gives me 0.25x divided, or 0.25x equals 3. So I need to divide by 0.25, which gives me an x value of 12. Plug it back in. I get y is 21. So I know that my x value should equal 12 and my y value will equal 21. All right, questions? Okay, before we try a couple more. Okay, take a look at this problem, 6.67. Okay, so the Alpine Music Club is going on its annual music trip. Club full of yodelers that like to play the xylophone. Last year, they this year they were taking their xylophones on a gondola to give a performance on the top of Mount Monk. The gondola conductor charges $2 for each yodeler, $1 for each xylophone. It costs $40 for the entire club, including xylophones, to ride the gondola. 2 yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. Okay, so a lot of information. Let's focus on that second paragraph right there. Gondola conductor charges $2 for each yodeler, $1 for each xylophone, and it costs $40. 2 yodelers can share a xylophone, so the number of yodelers on the gondola is twice the number of xylophones. What I want you to do is try and take a second here and write an equation, okay, that's going to represent those 2 scenarios. All right, so how can we write our 2 different equations? Okay, first one should be the money one, which is fairly easy, I think. How can we represent the money? It says the gondola conductor charges $2 for each yodeler, $1 for each xylophone. So actually, before I do that, we're going to represent our variables. So we're going to let y equal the number of yodelers, yodelers. We're going to let x equal number of xylophones. So if we charge $2 for every yodeler, $1 for every xylophone, it costs $40 altogether. We should be writing that as 2 times y, or 2y, because it's $2 for every yodeler, plus $1 for every xylophone, for a total of $40. Don't necessarily need the 1 in front of the x. Okay, the second aspect is that 2 yodelers can share a xylophone. So the number of yodelers is twice the number of gondola, or twice the number of xylophones. So y equals 2x. So now we can use substitution. Take this 2x, plug it in for that y there. We get 2 times 2x plus 1x for a total of 5x, or x plus 1x. Divide by 5, so x equals 8. So there's 8 xylophones. We got to plug it back in, figure out how many yodelers. Y equals 2 times 8. Okay. So with a word problem like this, we wouldn't want to write it as a point. We'd want to say there were 8 xylophones and 16 yodelers on the trip.